Okay. Hello, everybody. Can you hear me?
Yes.
Yes.
Shall we start?
Yes, please.
Okay. So good afternoon, or maybe for some people, good morning or good evening. Dear participants, ladies and gentlemen, it's my pleasure to welcome you to this number 3 special session of the A3R International Scientific Conference. I am Pinjing from Tongji University, China, and the Special Committee on Rural Waste Management belonging to China Association of Urban Environmental Sanitation. It's my great honor to chair this interesting special session. Here, at first, I would like to thank for the conference organizer, the Japan Society of Material Cycles and Waste Management, and Professor Mitsuzu Asari and Professor Reiko Sodano for their invitation and organization. We're here today to focus on the topic decentralized technologies, equipment, and its techno-economic assessment for municipal solid waste treatment that we feel is of great importance. Since decentralized technologies are in great demand for municipal solid waste management in rural areas in order to reduce the cost of transportation. So this special session, we would like to invite 4 researchers and engineers in the field from India, Japan, and China to present up-to-date progress regarding technologies and equipment for decentralized treatment of solid waste. I hope this special session will enhance communications between researchers, industries, and all participants. There are some basic rules for our 4 speakers. Please limit your presentation in 15 minutes. And at the end of the session, we will have a question and answer time on today's topic. So now let me open the session. The first presentation is equipment of intelligent by conversion of perishable waste via insect, housefly, larvae, and virilization technologies. The speaker is Dr. Guangyu. He is post fellow from Institute of Waste Treatment and Reclamation, Tongji University, China. And the co-authors are Dr. Fan Lu. She is professor from Tongji University, China, and Mr. Honghui Cai. He is president of Ningbo Qihe Gabriel Agricultural Technology Company, Ningbo, China. So, okay, now please start your presentation, Dr. Cui.
Okay, thank you, Professor He. You see my starting?
Yes.
Starting slide, okay. Good afternoon, everyone. My name is Cui Guangyu from Tongji University. I will speak on behalf of Dr. Lu Fan and Mr. Chai Honghui for this presentation. And also very glad to communicate with everyone about some important environmental concerns. Okay, today's topic about intelligent bioconversion of the food waste via housefly larvae. Firstly, let me introduce the status of the food waste generation in China. As we can see, the generation amount of food waste is increasing over a year with a maximum amount of around 0.3 1.13 billion tons per year in 2020. And the impurities, including plastics, bone, metals, textiles, and so on, accounting for approximately 10%, since the food waste are commonly characterized by high water content organic substances. Pollution. Given that the fact mentioned above and the faster society development in recent years, in our country, several government departments, include State Council, Ministry of the Housing and Urban Rural Development, Ministry of the Ecology and Environment, as well as Ministry of the Agriculture and Rural Affairs, released related policies and regulation about waste sorting and sourced resources utilization. Now, the national work is underway. As shown in the figure, there are different features of the currently applied approaches for the treatment of the food waste, such as anaerobic digestion, composting, as well as the feed processing. For anaerobic digestion, although there are high extent of harmless resources utilization, high cost and technical risk usually makes the technologies unstable. And anaerobic digestion is commonly not suitable for the rural areas due to the cost of long distance transportation. In addition, for composting, the long treatment time and low quality product are also problems. And homologer issued of feeding processing may lead to quite high policy risk, even though the technology has high harmless and reduced levels. Therefore, proper approaches for the treatment of the food waste or perishable waste to achieve the sustainable development of the economical society is urgently needed, especially for the rural area. Furtherly, by the way, to achieve the sustainable development of the world, in the general debate of the 75th session of the UN General Assembly in 2020, our President Xi promised that China aims to have CO2 emission peak before 2030 and achieve the carbon neutrality before 2060. Well, by conversion of the food waste by housefly larvae or a black soldier fly is regarded as a solution due to the high waste reduction rate and valorization level. Therefore, here we will share the state of the art and the technology. It's the intelligent equipments and the practical case. This slide shows the technical flow of the bioconversion of the food waste via housefly larvae. As we can see, the treatment system has 3 parts, mainly including pretreatment, bioconversion, and separation. In the pretreatment process, transported and weighted waste are firstly sorted, crushed, and grounded to obtain the clean and homogenized waste. Then some micro agent or rice bran powder are added to improve feed properties for a good palatability of house life. After that, through the automatically guided vehicle system. Okay, sorry. After that, through the AGV, automatically guided vehicle system, feed are transferred to the breeding zone for housefly bioconversion, which will significantly save coverage area compared to traditional mode. At the same time, smart algorithm system will automatically adjust the environmental condition and operating parameters in order to achieve the high treatment efficiency of the food waste. After bioconversion for 3 days or 4 days, we can harvest larvae and residues after separation using automatically equipment with functions of the optical sorting and vibration. The harvest larvae are normally stored in the freezer for use, further used or boiled for further processed. And the residues normally is furtherly composted for several days before used as the organic fertilizer or as the green organic media. Now I will share the key technologies of the houseflies bioconversion, including the iSmart, algorithms, and AGV system. Firstly, we need to put some important operating or environmental factors such as the temperature, humidity, oxygen, water content, and so on into the iSmart algorithms system. After calculation of the narrow network, we can know the optimal operating and draining parameters such as heating, ventilating, and mixing. Then the information will respond to AGV system to further optimize the bioconversion performance. Using iSmart algorithms can shorten breeding period until 3 days, and there are lower energy consumption. I shared another key technology is called AGV system, automatically guided vehicle in the bioconversion system. AGV system could achieve the 3 important functions, including feed, larvae distribution, turning through, automatically harvest. Therefore, the AGV system could efficiently improve the breeding environment and reduce the manual intervention. In other words, it can reduce the whole cost. This slide shows the AGV model and the site AGV that located in organic waste recycling center in Nanjing, Jiangsu province. In detail, you can see the AGV include the feeder hopper, meter larvae collector, and so on, base and elevators. Of course, bioconversion of food waste via the housefly larvae certainly generate moderate gases such as ammonia, hydrogen sulfide, and methyl mercaptan, and so on. Therefore, in order to protect the environment inside and outside of the workshop, control method is needed. Here is a centralized waste gas treatment system with the spray tower coupled with active carbon absorption is applied to treat the gathered waste gases that are generated from the workshop. The tower is a spree tower. And the lower object is absorption device with the active carbon. Of course, we can get two products. One is the solid residues after bioconversion. It contains rich antimicrobial peptide that can resist plant disease and pests. However, I'd like to share some data about residue properties. You can see many indicators completely meet the threshold of the agricultural standards NY 525/2021. These indicators include pH, water content, chloride, or organic matters, 3 types of nutrients. But you also can find the germination index is very low, only 25%, compared with the threshold 70%. And anaerobic digestion index, as we call the AR4, can reflect the biostability of the residues. The AR4 is the 152, quietly higher compared with the threshold 20. So these results suggest the residues after bioconversion by housefly larvae is not matured and needed to further composting. By the way, as mentioned before, solid digested from the anaerobic digestion is also a very inevitable and annoying product. Here, we are conducting attempts for treatment of the food waste and anaerobic digest via housefly larvae. This slide showed some of the experiment photos. Here, this solid digested from the dry anaerobic digestion facility, a food waste bioconversion processing. As accepted, we find the highest waste reduction rate and the highest stability and the germination index. The related mechanism is explained by the balanced meat and vegetable. Another product is mature housefly. It is verified that housefly larvae contain the rich crude protein and amino acid. So it can be regarded as excellent and multi-purpose feed for fishing or livestock. As people use the pulp shell of the housefly to make many premium products. Here I share some photo product from the pulp shell. Besides the advantages in bioconversion technology and the final product, profit model is also competitive. In China, the companies can get a government subsidy around 15 to 70% in total. At the same time, the business model is BOT. Processing fee is around 150 to 300 yuan per ton. And the time limit is 20 to 30 years. Since there are good products sale for protein sourced and organic fertilizer, therefore the treatment approach have very good economical effect. Again, the slide shows the projected investment and the benefit. Take a case with the capacity 100 ton per day as example, we can see the total investment is around 35 million yuan, include the fixed assets and the current assets, while the benefits is around 62 million yuan per year. This slide shows some information about the coverage areas, the populations, the environmental, investmental benefits, and so on. A small scale plant, capacity around 30 ton per day food waste. The photo shows the Nanjing Organic Waste Recycling Center. Currently, the plant can treat 50 ton per day of food waste. The left one shows the AGV in operation. The middle one is the bioconversion workshop, and the right one is the separation workshop. Just I mentioned the principle of separation is to achieve the separation of adult love and solid residues through the combination of the light and the vibration, so as to reduce the labor cost and improve the processing efficiency. Considering many advantages of the treatment approaches, it is expected that relative the large-scale plant with a capacity of the 50 to 500 ton per day will be applied in the future. This image is the bioconversion based of the multiple source of the food waste or perishable waste, such as the livestock manure and the food waste in agricultural zone in Zhejiang province. That's all. Thank you very much for your attention.
Okay, thank you, Dr. Cui, for sharing a very interesting topic. Now, let me introduce the second speaker, Mr. Qingping Xu. Mr. Xu is from Shenzhen Xuying Environmental Technology Company in Shenzhen, China. Dr. Tomonori Ishigaki, he is Chief Senior Research from Material Cycles Division, National Institute for Environmental Studies, Japan. And the topic of his presentation is mechanical and biological treatment of urban waste in Asia. So, okay, now it's your time. Dr. Ishigaki, please start your presentation.
Thank you, Chairman. Okay, let me start my presentation. Well, okay. Again, my name is Tomonori Ishigaki from National Institute for Environmental Studies in Japan. Today, I'm going to talk about the mechanical and biological treatment to complement the centralized technology. I don't think this is really topics on a really rural area, but more like a small scale municipality or medium scale municipality. But I hope this topic is also very interesting and helpful for audience and panelists as well. Just before I go into the main, just before I go to main topics, I'd like to talk about some situation in Japan. Currently, in Japan, we are facing a super age society, which is defined as the ratio of the old age person in population exceeds 21%. But it is not only in Japan, but very soon, other countries in Asia, like Korea, China, Singapore, Thailand, is going to be a super age society within 10 years or 20 years. On top of that, other countries like Indonesia, India, or Philippines is also going to be age society or super age society very soon. So I think this is very global and common issue, especially in Asian countries. So in this situation, many local authority is struggling to or managing their budget or expense to serve their public services, including the waste management. This is also Japanese case, but like a medium-scale municipality, oh yes, the 30% of medium-scale municipality has issued the municipal bond on waste management to obtain the waste management expenses. And 40% of them already highly depends on the municipal bond to operate the waste management. I mean that more than 10%. So something like this, the many municipality is becoming or facing the financial difficulties and try to find out a good solution on this situation. And this situation also strongly relates to the Japanese situation on municipal solid waste management. And this is a typical waste flow in Japan. As just quickly introduced that this is the total amount of waste generated in 1 year. And finally, the 80% of them is finally sent to the thermal treatment plant. And this ash or some residue is going to the landfill site or recycling processes. So that is very effective to reduce the waste volume as well as sanitizations. But together with that, the many smaller scale municipality is starting to be more difficult to manage these centralized thermal treatment process to treat the waste management appropriately. This is also another side of the, The thermal treatment plant is also have another problem or situation that they are going more centralized processes or to be centralization to increase energy recovery efficiency, so that you can see that the total power generation from the thermal treatment plant is increasing, as well as the increase of the average of power generation efficiency. So they are more like make a larger furnace or larger plant and increase power generations. And together with that, this is a kind of the more or make the municipality more difficult to find out the expense for managing this kind of the larger plant. So simply, I should say that the most smaller scale or middle scale municipalities still owning this kind of the smaller scale capacity of the thermal treatment, and this plant is becoming the out of trend of the power generations. So they should find out, they should replace this treatment system to be more sustainable or feasible on their financial or even technical situation in the local characteristics. So today I suggest or introduce the mechanical and biological treatment that is considered as the sustainable or feasible solution for the municipality, which is facing the financial problems or even needs the efficient management of municipal solid waste. This is not only a Japanese case, but also, as I already mentioned, it is a very common issue in Asia, especially in terms of the financial problem. I mentioned about the super age society. One is one situation to be struggling the financial problems, but together with that, some region or municipality which is still under development. In this case, they are also having the financial problem. This is different reason, but the same problem on the finance. So in this case, some region or municipality still is so far from the centralization, so that the mechanical biological treatments should be considered as a transient technology as well. A mechanical and biological treatment, so-called MBT, is the combination of the mechanical processes, including the waste preparation, shredding, crushing, or separation, or any other kind of the physical processes, and combined with the biological process, including the aerobic degradation or anaerobic digestion or bio-drying or other kind of the biological treatment. The order of mechanical process and biological process and very flexible. It's not fixed, and also applicable technology is very flexible. So each local municipality can select the best system, available system with the local existing technology. The main output of the MBT is the so-called refuse drive fuels, or sometimes it is shortened by the RDF, to be sent to some industrial or the public user of the fuels. And also other output is the debris that is not worth for being fuel. The mechanical biological treatment has been developed in the European countries as a pre-treatment method before landfilling to reduce the amount of waste, especially the organic composition, before landfilling. So the strong benefit is the production of the RDF, refuse derived fuels. Sometimes it is called as solid recovered fuels, which is a separated fraction of high calorific value from the waste. Of course, there is strong benefit, but together with that, we should consider or find out the secure user of this fuel. So finding these or securing this user must be a critical factors for successful implementation and operation of MBT. There are several benefits of the MBT, like yes, it can reduce the volume of the waste very efficiently, and also it has a function of the sanitization through the biological processes. And in terms of the technology, this process is highly feasible of using the combination with the existing local technology, and we don't require any advanced technology or high-end machines. And that is very helpful for the municipality which wants to save the budget or expenses for the waste management. In terms of resources, yes, production of the fuel, RDF or SRF, should be the very strong benefit in terms of the sales. And also that is also contribute to expand the share of the renewable energy in each region or in the country as well. And not only the fuel side, also we produce debris, but the debris or residue is a bad name. So sometimes we call the compost-like organics, or CLO is a better name, and try to find out to utilize these materials as for materials for backfilling or materials for temporary covers, which could be utilized in the civil engineering site or construction site. And it can also contribute to reduce the greenhouse gas emission or to reduce the landfill-related pollution if we can appropriately manage the debris. And this is also very important for local and smaller scale municipality about the finance or economic aspect. Yes, MBT is known to be a lower energy intensive technology compared to the other centralized waste treatment processes. And also the sales profit of the fuel is very attractive for the municipality as well. So again, I like to emphasize the reason to implement the MBD for municipal solid waste management. One is that it is very practical and sustainable and feasible sanitary pre-treatment of the waste. And it can save the landfill capacity as well. And also it can enhance the renewable energy production and utilizations. And if possible, we can also appropriately manage the debris so that it can contribute to prevent the pollution or emission from the disposal site. This is a typical mass balance in one plant in Germany. I think this is very representative data. And yeah, and in this mass balance system, in their systems, they adapt the mechanical process first, then send to the biological process. And they produce the SRF fuel, about 20% of the initial input waste. And they also generate the debris, about half, 50% of the input waste, and send it to the landfill site. This is just because of local situation and also acceptance in the fuel users and landfill site. And, oops, sorry. Yes, compared to the European situation, the big difference in Asia should be the waste characteristics. The waste in Asia is highly moisturized and also containing the highly degradable fraction compared to the other area. And sometimes these factors could be a certain barrier to implement the MBD. So this is also mass balance in one plant in Thailand. It's Thailand case. They implement the biological process first and then send to the mechanical separation process. But anyway, they produce the fuel around 28% of the initial input waste, and their debris was surprisingly small. It's just 7.5% of the initial waste. I think this is due to the high moisture and high degradation fraction, so that the vaporization, that the drying process can reduce the weight, and also biodegradation can decrease the organic composition. So that can contribute to reduce the waste weight. But anyway, this is very effectively reduce the waste weight. But there was one problem that the fuel was sent to the sell to the private industry, but that industry side, sometimes the fuel doesn't meet their criteria, so they should reject it. They should reject a certain amount of the fuel and return back to the MBD side. So it should be generally reprocessed, but maybe it contributes to increase the debris. So I guess the substantial amount of the debris, it could be 15 to 20% by our estimation. But even though this process can effectively reduce the waste amount to be disposed. And I can simply say that the MBT's benefit is larger than its cost. This regardless the size of the scale of the municipalities. This shows that the CBR cost-benefit ratio, and if this CBR is positive, more than one, it means that the benefit is larger than cost. And in this case, both cities show that the higher CBR, it means that the benefit is larger than cost, especially the RDF cells will be very important to make it positives. But still, you can see that the landfill fee should be a certain cost for these systems. So if we implement the additional treatment of debris to utilize this debris to be in the construction site, so we can compress the landfill fee like this, and also we can expect the sales profit of this material as well. So this implementation of the additional process could improve the CDR, both scale of the city. But anyway, you can see that the economy of scale or city size is very important factor, key factor to implement MBT, and also RDF cells. So we can say that finding out a stable user should be also very important, and also compressing or reduction of the landfilling cost by the appropriate debris management is also essential factors for successful operation or implementation of MBT. Just I like to conclude my presentation here. MBT, it could be recommended for the municipality or region that is struggling for the financial problems. The reason should be the financial problems should be caused by the super age society or still just under urbanization. But important thing is this is recommended for the region or municipality, which is still not so suitable for implementing the centralized process. And also important thing is that we need a certain industrial background or accumulation of industry for securing the fuel utilization. So it is very good things if we have the certain local industry like a cement industry or paper manufacturers or wood industry. They can use the many fuels, and also they need a certain reduction of cost for fuels. Or if there are some remaining capacity of the power plant, it is also a potential user of fuels. So anyway, a selection of this MBT technology is depending on the scale of cities or industrial accumulation, or also we needed to analyze these information so that the logistics should be very important. That's all my presentation. I hope this is very informative for audience and panelists in this session. Thank you very much. Thank you, Chairman.
Thank you, Dr. Ishigaki, for your nice and very clear presentation. So, in fact, we have another and the last presenter from India. So, dear Secretary, I'm not sure is Dr. Rishirana available or not. Hello?
Well, thank you so much, Chair. I actually sent her a reminder, but it seems that she has not joined yet.
Okay, so means we can now move to the question answer time, right?
Yes, yes, please go ahead.
Okay, so anyway, thank you for our three speakers for your wonderful presentations. Now we have question answer time. If you have any question, please feel free to ask, or maybe you have any comment. And you also can type your questions or comment in the chat box. Okay, so any question for our three speakers? And I noticed in the chat box, there is a question for Dr. Cui, and is about the difference, between the housefly and we know the black solid fly. Can you give some very brief introduction about the difference?
Okay.
Yeah.
Thank you. These are good questions. I think the main differences of the both in size is that the housefly larvae have faster waste digestion ability compared with the blacker soldier fly, which caused the higher efficiency for treatment of the food waste. And normally, treatment time by a housefly larva is 3 to 4 days. Well, the treatment time by the housefly larva is 2 weeks, more longer. At the same time, the nutrients of the housefly larva is higher than that the black soldier fly. That's my answer.
Okay.
It's okay.
Any question or any comment for Dr. Cui's?
I see, yes, from the Guangyu, June, maybe from the Korea.
Okay.
The greenhouse gases emissions for bioconversion, where housefly larva is actually lower than compared to the conventional method. I don't have the exact data for this amount. I can give you approximately amount around 20 to 30% degree decreased than compared traditional method.
Okay.
Okay.
Okay. Thank you. And
Thank you.
I noticed there is a question in a chat box for Dr. Ishigari about your presentation. Dr. Ishigari, have you noticed?
Yes, I found one in chat box and one in Q&A section.
Okay.
So I like to answer about this.
Answers or
yes.
We can discuss something. Yes, I'm also very interesting because in your presentation slide, I noticed there is a photo. I think I don't know if I'm right. There is a city, Mitoyo, Japan, in Japan.
Yes.
You show us a photo. I also very interesting. Is there any kind of facilities you use MBT process to treat your municipal solid waste, and some the detailed information, and also you give another slide show you the application in Thailand. And could you give some detailed information for these two applications? So thank you very much.
Okay, one is about the Japanese case. Yes, you're right. Mitoyo is the one of the Japanese municipality in Japan, which is applying the MBT technology. This picture was taken in Mitoyo City. The left-hand side is more, it's just kind of separation processes, and this is the apparent fuel to be sent to the private industry. And its capacity is something about 10,000 tons per year annually. And today I didn't show this slide, but yeah, briefly they say that they apply the aerobic process first. They call that the tunnel composting, but it's more like in-vessel composting processes, and they then send to the mechanical separation processes. And the fuel efficiency, production of fuel is 27% of the initial input. And surprisingly, their debris is sent back to this MBT process again. So they, as something like a return composting, as an inoculum of the biology, microorganism, sorry, so that they don't went out any kind of debris for disposal. So this is very kind of the closing system. So it is very unique, and I should say that is not so. Of course, that is not so common in Japan, but I know that some other municipality is also try to follow this system. I mean, that expanding this technology in Japan as well. And this is Japanese case, and also I like to show the Thailand case. Yes, as you can see, this picture in this is a bio drying process, but this is the outside process. So they have huge land, they prepared a huge land for drying, like making such kind of plain waste layers with some aeration system as well. So that it takes a very long time. As far as I remember, it may take 90 days or 100 days or more sometimes. But at least there is a very cheap cost, or I should say that we can save the cost of operation of the drying process and then send to the mechanical separation. I see that you can see that the size of the scale is 18,000 tons per year, briefly, I should say. And in Thailand case, I remember some other city also have these kind of system, MBT systems, and the scale is ranging about as far as I remember, I mean, start from 5,000 tons per year, and I think this city, 18,000 is one of the largest scale in their country so far. And this is the situation in Japan and Thailand. And also I have one more question in Q&A about I will call this question. He'd like to ask about the oil extraction of food waste in Japan. And he said in China, it is very common to extract oil from food waste in the pre-treatment of LAD. Does the LAD plant in Japan do that? And as far as I know, yes, today I talk about the municipal street waste, but food waste is mostly categorized in the industrial waste or some business waste. In this occasion, yes, we don't call oil, but the grease itself is a kind of the inhibitant for the good treatment for anaerobic digestion or composting as well. So removing the grease is very critical part of the processes. And such kind of removed grease is also tried to utilize to produce some fuels like biodiesels or any other some valuable materials, valuable organics to be utilized. Yes. As far as I know, it's hard to directly extract the grease from the municipal waste. But if we have the certain segregated food waste, yes, that is a kind of the target of the removal and utilization of grease in the, I should say, oil in the contained in the waste. I think so far that's all for my question.
Yeah, okay, thank you. And Dr. Cui, do you have any comment?
Yes, I see another question
oil
from
or grease
Malaysia.
In waste in China, and of course we need to pre-treat the waste and try to extract some oil or called grease from food waste. Can you give a very brief introduction?
We used yes, three-phased separation facilities to remove the oil and grease before further treatment. Example is anaerobic digestion or bioconversion by housefly larvae.
First, we will heat the food waste and use the centrifuge to separate the oil between the food waste and the oil. That's the process. So that's the doctor just mentioned. We call the three-phase separator.
Separation. Yes.
Yeah. Okay, so I noticed that there is something comment.
Oh, yes.
Questions in chat box. So anybody will?
Yes, from Malaysia.
Malaysia.
And Qihe.
Yeah.
So how to control the order? Actually, I want to show you the slide. just
And I think this question is not only for you, but also for Dr. Ishigari. Especially, I also have some doubt about the last slide Dr. Ishigari just showed us in Thailand case, the photo. So how to control all the emission in MBT or BMT.
Yes.
Yeah. So please, Dr. Cui first.
Okay, for the housefly bioconversion systems, here is I show the precise flows diagram. We can regard as this one as a workshop. So here inside of the workshop, the pressure is negative, so we can can avoid the odor emission to outside. After that, then we collect and gather the molder gases into the waste gas treatment system. Just I show you here. Then into the here, and this one is the spray tower. So the molder gas is absorbed by some degraded by microorganisms, and then here this one is the second grid, second spray tower. Here is a carbon dioxide box. So finally, some gases, some remaining gases can be treated by active carbon through the absorption.
Okay.
Thank you.
Any question or comment? Okay. So I still have a question for Dr. Ishigari, because we are very interested in the waste treatment in Japan. So my question is there any good technology or suitable technology used in Japan now for the, the decentralized, the technology or equipment now used in Japan? Can you give us some introduction?
Well, in terms of the decentralized, well, today I talk about the MBT process, and some small scale municipality is going to select this technology from replacing from the thermal treatment technology. And if I say that more smaller, very small rural area, I think that they try to have more like more segregation, segregating some organic food waste from municipal street waste, and utilize more like some biological processes like anaerobic digestion or composting processes. I think these activity or practices also are being increased in Japan as well. But I think maybe the scale, consideration of the scale in the municipality is much different from Japan and China. If you said rural municipality, I know it is still very big, a big population as well. Okay. So I have one question in Q&A or chat box from audience about the applicability or suitable, is it suitable to apply in rural area in China? And he asked the limitation of MBT. But I think, yes, if I say about the rural municipality in China, I think it has very good benefit or suitability to apply MBT. But together with that, if the rural area in China, I know your country or region is rapidly increasing. So if the city or population grow up so much early, so in this case, you also consider about more like a centralized processes. So we should consider about the criteria when we consider about the decentralized process or more like start to consider about a centralized process. I think this is a key criteria factors to consider from now on.
Okay.
But
so
at least
I remember, excuse me, I remember in Japan, you developed, in some years ago, you developed some technologies, you know, the pyrolysis or gasification technologies. Is there any, do you have any comments about the pyrolysis or gasification technology? Do you think it's good for centralized? I mean, or we can say the small scale, or maybe 100 tons per day, or maybe 50 tons per day, which is not good for waste of energy facilities. I mean, the waste for energy, no incineration, large scale incineration. So it's very interesting about what you are thinking about.
Well, please accept I'm not the real expert, technical expert on that area about the gasification or pyrolysis. But as far as I know, as just an expert in the waste management field, yes, gasification and pyrolysis is also being active in Japan to develop or to implement to treat the waste. And in terms of the gasification, yes, not only gasified, I mean that as in terms not only for the viewpoint of the waste treatment, but also produced gas, syngas, could be also utilized in the industry. So this is very more like such attracted in not only the municipality side, but also the industry side is going to focus on to apply more. And I think, as far as I know, this is still being expanding, also making the bigger size of the treatment plant as well. And together, on the other hand, for pyrolysis, of course, that is also very actively developing now. But I think it is more like a purpose is very specific, which kind of material to be produced and utilized in industry. So that, as far as I know, this is not so much becoming very big. I mean that not going to the centralized process, more like they keep the middle scale or small scale plant that is focusing on the very purpose specific production of the recycled material from the pyrolysis. This is my understanding.
Okay, so I still want to know, is there any application now in Japan for the pyrolysis?
Yes, especially for industrial waste. Yes, we have many.
Industrial waste, but not municipal solid waste. For
municipal, I know some facility but I don't know it's really operating or how much they are being successful or not. So, but we have the facility.
Okay, good. Thank you. It's clear. Okay, so dear Secretary, I still ask a question. Can we expect Dr. Rana? Is it possible for his availability or not?
Well, so far,
okay.
We haven't seen her participation.
It's okay. So any other question or comment? Okay. If no, so I think it's time for us to close this meeting And I will very appreciate our three speakers for your very interesting presentation and for your participating for the discussion. And if you have any more questions, please contact with us after this session. Again, many thanks, okay, for all the participants, and please keep healthy, and see you in somehow next time. Thank you. So now I will announce to close the session. Bye-bye.
Thank you very much.
Thank you.
Thank
Bye-bye.
you, Professor. Very nice facilitation.
Bye-bye.
Thank you.